Hello, this is section 3.6 of our college algebra book. Excuse me. And what this one's going to be dealing with is it's going to be dealing with rational functions and their graphs, and as far as how to graph rational functions. So anyway, before we get started, there's a couple things that some terms and whatnot that we're going to go through, and as far as how to find them. Rational, first of all, meaning it can be written as a fraction, and function just meaning a machine, just like what we've been dealing with in this chapter, in the past two chapters, that is. But anyway, there's a couple different things that we have when we deal with graphing them, and the first thing that we're going to talk about are asymptotes. Now, an asymptote is like an invisible line. Okay, it means that it can come right up to it, but can actually cross it. My analogy that I use with that a lot of times is it's like an invisible shock collar for a dog. You know, like the invisible fence. Anyway, it's there. They can't see it, we can't see it, but as soon as it gets up to them, it gives them a little shock. And it's kind of the very same thing, where it's going to come right up to it, but not ever cross it. Vertical, meaning it's going to run up and down. And in order to do that, what you're going to do is you're going to set the bottom equal to 0 and solve. And this is where you're going to have your vertical asymptote. So you're going to have a vertical line running straight up and down based on that number, whatever number we get there. Another type of asymptote that we can have is called a horizontal asymptote, meaning it's going to run horizontally, okay, or left to right. This one's a little bit more complicated. It's more of a pattern as far as how it happens. Horizontal asymptote has three different criteria. The first one is when you look at the top degree versus the bottom degree. And the first scenario is the top is less than the bottom. If the highest exponent on the top is smaller than the highest exponent on the bottom, then my horizontal asymptote is y equals 0. Now there's no solving or anything. You just look at and identify how it relates. The second scenario is if the top degree is equal to the bottom degree. So if they're the same exact number, you know, if the highest one's 2 on the top and 2 on the bottom, then we have this. And how this scenario works for this one is now we have y equals the lead coefficient of the top divided by the lead coefficient of the bottom. And again, what we mean by lead coefficient, we're referring to the number in the front of the highest exponent. Okay, so that's what the lead coefficient is. The third scenario is if the top degree is bigger or greater than the bottom degree. Okay, so if that's the case, then there is none. All right. These are the main two asymptotes that we have. Vertical and horizontal are the two main asymptotes that we have going in. But there is another one. Another asymptote that we also have included in here is called a slant asymptote. And a slant asymptote is a line. Okay, it's like the other ones are vertical and horizontal lines. These are slanted lines or diagonal lines, or however you want to have, whatever you want to do. These ones only happen when the top degree is exactly one more than the bottom degree. Okay, and as far as how you find it, you long divide. I know that synthetic division is probably more User-friendly, but we have to long divide. And when we long divide, the quotient, or the stuff at the top, is the line. We actually do not need to go any further with that. Once we get the line part, the remainder actually doesn't do anything for us when we are finding the slant asymptote. Okay. Now, above and beyond that, some other things that also do happen with this is that we also want to find intercepts. Okay, and we've talked about intercepts in a different section before, but just to remind you, first of all, about the y-intercept. In order to find the y-intercept, what you do, the easiest part is you take the constant of the top divided by a constant of the bottom. When you put 0 in for x, that's all you're going to have, is you're going to have the constants left over. So that's just a quicker way of doing it. Is you take the constant of the top divided by the constant of the bottom. And as far as the x-intercept goes, okay, as far as the x-intercept goes, then we set the top equal to 0 and factor. Okay, so that's what we're doing to find the x-intercept. Is we're going to factor the top and then set it equal to 0, and then put those on there. The more points you can actually put on there, the better. Therefore, the more accurate you're going to be when you draw them. If it ever happens where when you factor the top and you factor the bottom, if there's a number that they share in common, those are commonly referred to as holes, meaning that you'll have an open space in the graph. That may or may not show up. They're pretty rare as far as when they do happen, but a lot of times it's just like an open circle on that line, or you might already have a vertical asymptote right there or something like that. So, but anyway, here's what you're going to be asked to do: is you're going to be given a problem, something like this. It says r of x equals 3x to the second minus 12x plus 13 all over x squared minus 4x plus 4. And it's going to ask you to graph it, state the domain and range, identify all the pieces. So for me, first thing I'm going to do is I'm going to go through all the different things and find everything I can before I even try to graph it. So the first thing I'm going to do is I'm going to do my x-intercept. So the x-intercept is where we set the top equal to 0 and we try to solve it. If I put the top equal to 0, 3x squared minus 12x plus 13 equals 0. First of all, if I try to factor that, it does not factor. So then that goes to, got to use the quadratic formula. If I put this in the quadratic formula, negative 12 plus or minus square root of negative 12 squared minus 4 times 3 times 13 all over 2 times 3. I get a positive 12 in the front. I get 144 there for the negative 12 squared. But then I get minus 156. And now my red flag comes up, because right there, that's going to be a negative number, which means it does not cross the x-axis. So as far as the x-intercept goes, there would be none. As far as the y-intercept, the constant of the top is 13, and the constant of the bottom is 4. So my y-intercept is 13/4, and it's pretty quick. It's nice. My vertical asymptote is where I set the bottom equal to 0. Now, typically speaking, I've noticed that this author likes to make them so that you can factor it, because they don't really want you to do a whole lot of decimal work. It's more whether or not you can get the line in the right spot. So factoring is probably going to work, I'd say 9 times out of 10. For this particular one, if I factor it, I get x and x, and if I multiply what times what gives me 4, but adds up to be negative 4, should be negative 2 and negative 2. Ends up being the same group twice. I only have to solve one of them. I don't need to do both. That's overkill. So I get an x of -2. That's a vertical asymptote, meaning I'm going to put a vertical invisible fence on x equals 2. As far as the horizontal asymptote, I'm only going to look at, I'm going to put it in blue just so that you guys see it, I'm only going to look at those two spots. How are they related? Is one bigger than the other, or are they the same? In this particular case, they are the same. So it's the lead coefficient on the top, which is 3, over the lead coefficient at the bottom, which is 1, or just y equals 3. Now, when the tops and the top degree and the bottom degree are the same, then as far as the slant asymptote goes, there would be none. Okay, so I'm not going to have any slant asymptote. I'm not going to put it there. That's kind of I'll put it in a different spot. So slant, none also. Okay, so as far as what I have here is I got everything working in my favor as far as labeling everything. I'm going to start to graph this now. I'm going to put, actually I'm going to use red for my asymptotes. X equals 2, I'm going to go over 1, 2, and I'm going to make this dashed line. Now a dashed line, all that means for me is, hey, it's there but not really. It's kind of invisible. And then y equals 3, I'm going to go up 1, 2, 3, and I'm going to make a dashed line going across that way. Okay, so for me, that's how I label my asymptotes. I don't necessarily make them in color, but I will have them as dashed ones, so that way they're there but not really. Okay. Now, as far as coming up with the graph, looking at my intercepts go, I'm going to put this in blue. 13/4, if I actually divided that, would be 3 and a little more. So that's actually going to cross like right in here somewhere. To get the picture itself, you can do a couple different things, and one of them that they suggest that you do is you try to put numbers in and see how it's working, but realistically, it's so much easier, especially with the graphing calculators, to put it in your graphing calculator and see what it looks like. When you're putting this in, put the top in parentheses, like so, and then versus the bottom in parentheses. And then I ran out of room there, but that's what I would do in order to do that. And when I do that, you'll get this nice little line here where all of a sudden it'll shoot up, and then it'll come back down this way and look something like that. Basically what it's doing is it's riding alongside those asymptotes that we created. It's not ever crossing them, it's just kind of riding alongside of them. Now I'm going to do one more with you, but realistically this is the entire section. I'm going to find all the asymptotes, I'm going to find the intercepts, and then I'm going to sketch the graph, and I'm going to label them. Oh, I almost forgot. One other thing about this is that with the domain and range. Domain is your x values, or from left to right. This actually goes from -infinity all the way up to 2, and then goes from 2 to infinity. And where I got the 2 from was the asymptote. Same thing for the range. Range is the y values, or from the floor to the ceiling, which nothing's happening except for from 3 to infinity. And again, I'm using parentheses for all those because that's not equal to. Okay, if it was an equal to situation, then we'd have the bracket, but for this we got to have parentheses because it's not equal to. So this one right here is the domain, and this is the range. Okay. I know it's a lot of stuff on one slide, but that's how all these problems look. There's a lot of information you gotta find with this. So I'll give you another one. Okay, again, I'm going to set this up just like they did the last one. So I'm going to find the x-intercept first, which means I put the top equal to 0, and I solve for x. So this particular one, I'm going to factor. What times what gives me x squared is x and x. What times what gives me 4, it adds up to be 5, is 1 and 4. And then when I put them each equal to 0, I get x plus 1 equals 0, or x equals -1. X plus 4 equals 0. or x equals -4. Then to do my y-intercept, again, it's the top over the bottom. Done. Nice and easy. Vertical asymptote, this one I made kind of simple because of the fact that it's only one thing. X minus 3 equals 0. I set the bottom equal to 0. I get x equals 3. The horizontal asymptote, looking at the degrees again, 2 on the top, 1 on the bottom. Top is bigger, that means it has none. But more specifically for this one is, it does have a slant because it's one more than the bottom, or the top is one more than the bottom. So now I'm going to show my long division, everybody's favorite. And I say what times x gives me x squared, which is x minus 3x. Draw your line, switch your signs, add straight down. I get 8x plus 4. And then I start over. What times x gives me 8x is plus 8. There's my slant asymptote. Y equals x plus 8. I do not even care to finish it. That is my asymptote. I am done. I don't have any more to do with that. So I found the intercepts. I found the asymptotes. Now it's time to sketch my graph. Now, when it has a slant asymptote, I've noticed this over the years that a lot of times when you're using your graphing calculator, you might only see one part of it and not the whole thing. Only because the asymptotes with the slant the graph gets to be so big, so you might have to adjust your window if you're going to put that all on there. If I put my vertical asymptote, first of all, I've got one at 1, 2, 3, 2, 2, 2, 2, 2, 2, 2. That goes down here. And then if I put x plus 8 as a line, 1, 2, 3, 4, 5, 6, 7, 8, where it crosses, up 1 over 1 for the slope. So I have this thing coming in here like so. That's what it means by a slant, is the fact that it's going to be a diagonal. Now as far as putting all my pieces on there, I have one at -1, 2, 3, 4. I have one at 4. And I also had the y-intercept at negative down here. When you actually type this in to your graphing calculator, you're going to see something that looks something like this, where it's going to come up here like that, and that might be all you see. So this is where I mean by you might have to adjust your window, because it will also, and this is where it's going to get goofy because I'm going to write over top of all my other stuff, it's going to also be up in this area here. And notice what it's doing is, it's riding along the slanted axis, but it's also going to ride along the vertical asymptote. The domain for this would be from -infinity to 3, union 3 to infinity, excuse me. Actually, they're not even going to ask you for the domain and range. I just had to look for when it comes to slant asymptotes anyway. But as far as section 6 goes, that's what they're going to ask you to do. If you look at the first couple slides, I kind of gave you a little bit of a rundown as far as how to do each one of them. Where x-intercept, you set the top equal to 0. Y-intercept, it's constant over constant. Vertical asymptote is bottom equal to 0. Horizontal, you look at the degrees. Slant asymptote, you have to long divide only on certain cases. And then sketch the graph. And as far as sketching the graph goes, the easiest thing to do, put it in your graphing calculator, see what it looks like. That's the easiest. So anyway, that's section 6.